So I'm doing this video on these Mitsubishi DLP TVs. It's the V26 chassis, and it covers the WD-52825, 52725, and the 52825, as well as the 62525, 62725, and 62825. This video addresses repairing multiple problems that you may have with your sets. Lines in the picture, distorted video, digital noise in the picture, won't boot, all sorts of various issues, green light constantly blinking, red lamp light coming on. And so let me show you a couple error codes real quick you can look for and fault finding. So here's some, from the service manual, some indications of some problems that you may have that may not be the electrical chassis itself. So you may want to freeze frame it and look these over really good just to see if you might be having any of these problems. One thing that I can tell you, this one right here where it says if the lamp LED comes on red, the lamp did not turn on. That can be caused by the capacitors in the power supply failing and the light engine only getting about 3 volts instead of the full 5 volts to operate on. So that's one issue that could be addressed by capacitor replacement. These other things, usually they'll actually be caused by, fan problems. I've had several of those. Fan stopped. I forgot to plug the DVI cable on. Yes, it does do this one on the bottom here. Things like that. So look this over, freeze frame it if necessary, and happy troubleshooting. So here's an electrical chassis out of a Mitsubishi DLP TV. This one's particularly out of a WD-62825G. A lot of the Gs have this little circuit board up here, which is the thermal controller for the cooling fan. And actually on a lot of the G series with the little circuit board, they tended to last a little bit longer than the models that have the constantly running fan. And there's a very good reason for that, which we'll get into in a little bit. It's got to do with the direction of the airflow out of this fan. So we're going to talk about rebuilding this chassis. This particular chassis is very hard to boot, which means the green light just continuously blinks. You can get it, if you work at it hard enough, pressing the reset button and unplugging it and plugging it back in, it will finally boot up. But when it does, it has severe lines in the picture, horizontal lines, primarily pink and green in color, which we will address as well. So we're going to start by just disassembling the electrical chassis, which I'm just going to show you real fast how to do that. It starts by removing the cover over the power supply, removing the bottom screws, 2 screws here, these 2 screws. There's one other screw here on the side in the back right here that needs to be removed. This one's already got the hard drive taken out of it, but it just is held in place. There's a screw right here. The metal bracket, which has already been removed, has a couple screws that hold the hard drive in place as well. So I've got the cover off the power supply. The first thing you want to do is when you get the power supply off is inspect some capacitors. The first ones are these 2 right here. These are 3300 microfarads at 10 volts. These 2 appear to be fine. They're not bulged or puffed up whatsoever. These capacitors actually supply the 5 volts to the light engine. When they're defective, it'll actually cause the lamp light to come on. The light engine will start. It looks like it's going to go good. The lamp lights and the lamp goes off. A lot of people are fooled into changing their lamps when they don't need them. The other ones we want to look at are these 4 1000 microfarad capacitors at 16 volts. These are the 3.3 volt standby power supply that runs the microprocessor in the TV when the set's off. So we want to make sure that these are good. They all look good in this one. Normally they're bulged when you have problems with these. Other than that, there's not really much more. Oh, there is one more capacitor down here. It's this little, I think it's a 10 microfarad at 50 volt. This little tiny one right here. It's hard to see because it's dark back up in there. When that one goes bad, that'll cause this set to begin to boot up and then stop. And then begin to boot up and then stop. The green light will blink 3 or 4 times and then it will pause, and then it'll blink 3 or 4 times, and you can also hear the cooling fan start to run and then stop, and then start to run and then stop. Primarily it's only affected after the set's been unplugged and it's allowed to cool off. Once it boots and it's warm, this capacitor has almost no effect on the running of the power supply. So let's get into the rest of the repair at this point. The next thing we're going to do is we're going to start by completely removing all the metal covers over this set. We're going to remove the cover with the fan, so you want to unplug the cooling fan from the little temperature sensor board. Remove the screw on the top. There's another screw down here on the bottom that needs to be taken out. This one right here. This cover will just pull straight off. After that, these 2 screws, these 4 screws need to be taken out. The ones under here, which hold the tin on, remove the 2 screws on the LVDS cable, and then this thing, you kind of have to work the wires. You have to remove these 2 wire clamps as well, and then you kind of got to work the wires out and around to get this tin cover to come off. And so I'm going to pull those off now, and we'll go. Now this set that I've got torn apart here, this is just an interesting little tip to see if it's your formatter board or your DM. This is only applicable on the sets whose models end in 525 and 725. It will not work on an 825 set. So if your set has this cable across the top, this will not work. If you get a set that won't boot, if it's just a green light that's blinking, unplug this 4-pin power connector right here from the formatter board and plug the set in. If it boots up while the set's still plugged in, go ahead and just attach the cable back on there. The set should power up and it should run. If that's the case and it boots with this cable disconnected, you know that your DM, the second board in here, is indeed good. If it doesn't boot with this cable disconnected, you know your problem's on your DM and not on your formatter board. Well, you still could actually have a problem with your formatter board, but most likely it's your DM that's causing it not to boot, so you want to address that. This video does not address all potential problems that you may have. You may have defective ICs. I've had bad voltage regulators. I've had bad microprocessors. And I've had EEPROM problems where they get glitched. So this video does not address that sort of repair. It only addresses capacitor replacement on this model. And I did get the set to boot up. I've got it sitting here completely torn apart on our test jig, which is just basically a D.L.P. TV that we have removed the top from so we can project it on the ceiling. That way I can actually work on the chassis here. And what we're going to be doing to correct this is we're going to end up changing the majority of these little surface mount, actually all of these little surface mount capacitors that are on, this is the formatter board, and the board behind it right here is the DM. We're going to end up changing all of the capacitors on the DM as well as the formatter boards to get this set up and running. Have a happy customer. So we're going to start by removing the DM as well as the formatter board from these sets. And it's done with removing these screws up here, all these screws here. This one we're going to take these screws out of the bottom right here. We're going to move the jack panel completely out of the way. We'll have to disconnect some of the plugs down here. And let's pull out the formatter board and we'll go from there. So I got this chassis running. I just wanted to show you what it was doing. Hopefully you can see it in the video, but there's a severe amount of lines in the picture. They're just all over the place. I've got it shining up on the ceiling in our shop here. So I've got the formatter board out of the set, and the first thing that I'm going to do is I'm going to start by changing the 4 power supply capacitors. This is what supplies the 3.3 volts to the rest of the board. Those are originally 1000 microfarad at 16 volts, but they're going to get replaced with 680s at 16. Has a different resonant frequency, and according to Mitsubishi at least, they're supposed to last longer than the 1000s at 16. And then we'll talk about replacing all of the other surface mount capacitors that are on this board. There's quite a few of them, but they're really quite easy to do if you know what you're doing. You can do it pretty easily. Just want to make this note. I've got the capacitors changed here, these 4 in the power supply, and I've replaced them, like I said, with 680s at 16. I just want to make a note that make sure that you use 105 degree Celsius capacitors and not 85 degree. So here are a couple of the capacitors on this board that I'm going to talk about how to replace. These are both surface mount 100 microfarad 16 volt capacitors, and you can try to unsolder them one end at a time, but I've always found, let me try to get my light positioned here, if you just take a pair of pliers, grasp the capacitor, and with a little bit of a downward force begin to twist, it'll actually fatigue the leads and it'll actually lift right off the board. So let's do the next one as well. You can look at that one. And there, it's off the board. Next, it's a matter of just taking your tip, add a fresh bit of solder to it, and you can just go through and wipe up these pads. They're off the board. Re-tin the pads. So we're going to replace these with standard electrolytic capacitors. So once again, I've got standard 100 microfarad electrolytic capacitors. We're going to heat one side of this, heat the other side, touch up the first side to remove any stress. So there's one capacitor replaced quite easily. We'll do the same on the next one. So I've already pre-tinned the pads. Occasionally it might be necessary to add just a droplet of solder to keep it nice and fresh. Make sure your connections are nice and shiny, that they don't have any cold joints. They should be bright and shiny just like that. And so that's the example of replacing the capacitors on this board. You just have to do this about 100 more times and you'll be all ready to go. Just one more quick note. You will find some capacitors on these boards that are non-polarized, which means they don't have a positive or a negative, and they need to be definitely replaced with non-polar caps so you don't have problems down the road. Alright, so here's our formatter board after we've gone through and changed all the capacitors on it. Just be careful when you change these little tiny ones around the LVDS jack. They need to be laid flat, otherwise the cover will not go back on. So we've got the DM board out of the set. We're going to start changing caps. All the surface mounts need to be replaced on this board as well. There's a couple hiding down here on the bottom. Pay particular attention that these capacitors down here, there's a couple of bipolar caps right there. There's 3 of them actually. All 3 of these down here are all bipolar, non-polarized capacitors. As well as there are a couple of them over here. Those 2 right there are both bipolars as well. So just pay particular attention that those get replaced with non-polar capacitors as well. And on this board, it's not necessary to take the board out of the cradle to replace the capacitors. Power supply caps over here, those 4 capacitors can be changed. There's a large enough opening in the back that you can get to these 4,000 mics and replace those with 680s at 16. And there's the DM after I've gotten all the surface mount capacitors replaced with standard electrolytics. Always be very careful that you watch polarity on these capacitors. There's only one way they can go, and if you put them in backwards, you will have troubles. Let me just try to get in close here on one of these. You'll notice that on one side of the capacitor there's a flat line marked on the circuit board, and that's always going to be the negative side. The positive side will always have curved edges. You can see on this one the negative is to the right and the positive is off to the left. And I'm going to talk about height in just a second. I'm going to put the formatter board on top of the DM, and I'll give you some measurements to be careful of. These capacitors must be at a certain height or below, otherwise they'll interfere with the bottom of the formatter board chassis. So here what I've done is I've actually attached the formatter board to the DM board in its original little cradle here, like you would see in the TV. And what I've got here is my micrometer, and I'm going to measure the distance in between the two halves here, and it's about 15 millimeters. So you want to make sure that these capacitors, you can see this one, the light will show it just right, is it's got a little bit of clearance. They've all got probably 2 millimeters of clearance. If you look really close here, you can see those off in the distance there. There's a gap in between them. But you just want to make sure that you have enough clearance here that the capacitors don't hit. So just be careful that you make sure that the total height of the capacitors is going to be less than 15 millimeters. So here are all the capacitors that were changed. These are only the DM and the formatter board capacitors. These don't include any from the power supply. But these are all little surface mount capacitors that have been twisted off the board, as well as the 4 power supply caps on each board for the 3.3 volt power supply, the large electrolytics here. It's also a good idea to note, while you've got the formatter and the DM boards out, you should look at the signal board here, inspect all the capacitors, especially these large ones I've had problems with. In fact, we've got one here that is starting to bulge. I don't know if you can see it, but the top of it is starting to bulge out there a little bit, so it's always a good idea to check those and replace as necessary. Usually I don't have many problems on this board whatsoever, but we also want to look at the inside of the jack panel over here. There's 2 electrolytics. These 2 large ones right here, they are 1,000 microfarads at 10 volts on this particular one, and I've had those bulge as well, so you want to look at those and replace those as necessary. And here's our same chassis after all the capacitors have been replaced. As you can see, projected up on the ceiling. No lines in the picture at all now. It's got an absolute fabulous picture. And it's all taken care of. So it's sitting here playing. Totally disassembled, but it's running. The next thing I'm going to address is prevention to keep this from happening again. We're going to modify the chassis, and we'll talk about that in just a second. Alright, so here's the cooling fan for the complete electrical chassis. And as these sets were produced, when they originally left the factory, they had the fans reversed. So the airflow was up because, you know, as everybody knows, as heat rises, or as parts produce heat, that causes the air to rise to dissipate the heat. And so I've got this fan loose here, and so this is how they left the factory. And you can hear that sound. A lot of people complained about this initially, so Mitsubishi, when these DLPs first hit the market, sent out a service bulletin to all the servicers. If you ever get one of these in for service, simply remove the cover, take the fan, and reverse it like that, and the customer stopped complaining. But now the problem is the fan is pushing air down instead of pulling it up like it should be, and it creates hot spots inside the chassis. And so the way to alleviate this problem is to actually just remove the fan, take a pair of cutters, and go around and just cut this completely out of here. Okay, so I've got them all cut except for this very last one. So I've got that cut out of there, and I'm just going to set the fan back up there the normal direction, the way most of them are produced at this point. And you can hear the amount of sound that it makes. Now I'm going to reverse the fan. Compared to how loud it was before, this is perfectly acceptable. Now the air blows up out of the fan, so it actually pulls all the heat out of the electrical chassis. The only thing you want to watch out for, and I'm going to show you this in just one second, let me pause this. The only thing you want to watch out for when you reassemble the chassis are these wires right here, because this is the area that the fan sets. And what I normally do is I'll try to push them down and get them as flat as I possibly can, and then I'll put a zip tie under here, and just so the wires are forced down with the zip tie. I usually put the head of the zip tie right over here. So in essence, the zip tie covers the wires and pushes them down right here to keep them out of the fan blades, because there's about 1/8 of an inch clearance between these wires and the fan blades once you zip tie it down. And it'll keep the chassis much cooler than having the air pointed down, and allow these things to actually last much longer than normal. And so that concludes it for the rebuild of the Mitsubishi. This one, like I said, is a WD-62825G. And oh yeah, as I spoke earlier, I removed the thermal sensor board, and I'm not going to put that back in. And this way, it's going to cause the fan to want to run continuously. So it will not cycle on and off, so it constantly is going to cool this chassis down, so you won't have to worry about overheating anymore. And this also applies to the sets that end in 525 and 725. The only difference is they won't have this connector on the top to connect the formatter to the DM, and they will not have a hard drive in them as well.